Introduction Issues in High Performance Computing.
What is high performance computing? High performance computing is huge number of computational and memory requirements. It cannot be afforded by a standard workstation efficiently. It has higher speed. It has same concept as parallel computing and supercomputing. Parallel computing is computing on parallel computers, while supercomputing is computing on top 500 machines. Next is the example of supercomputing. When to use supercomputing or highly performance computing? Used to perform time-consuming operations in less time or before a tighter deadline. It used to do a high number of operations per second. What does high-performance computing study? It studies in hardware and software. In hardware, it consists of computer architecture and network connections, while in software, it consists of programming paradigms, language, and middleware. What is high-performance computing? High-performance computing is huge number of computational and memory requirements. It cannot be afforded by a standard workstation efficiently. It has higher speed. Next parallel computer architecture is distributed address space. Processor to processor data transfer are done over internal network topology, impose memory locality, high scalability, load balancing issues, and input-output difficult. This is the detailed view of shared memory multiprocessor and 4-node PC or workstation cluster. Key terms and concepts. Conventional serial execution, where the program is represented as series of instructions that are executed by the CPU, also sequential execution. Parallel execution of a problem involves partitioning of the program into multiple executable parts that are mutually exclusive and collectively exhaustive, represented as a partial ordered set exhibiting concurrency. Next is scalable speedup. It is relative reduction of execution time of a fixed size workload through parallel execution. Speedup equal to execution time on one processor over execution time on n processor. Scalability efficiency, ratio of the actual performance to the best possible performance. Efficiency equal to execution time on one processor over execution time on n processor times n. Strong scaling and weak scaling. Capability. Primary scaling is decrease in response time proportional to increase in resources applied. Cooperative. Single job. Different nodes working on different partitions of the same job. Capacity. Primary scaling is increase in throughput proportional to increase in resources applied. Models of parallel processing. There are three types of model parallel processing, that is decoupled work queue, communicating sequential processing, CSP message passing, and shared memory multiple threads. It has same concept as parallel computing and supercomputing. Parallel computing is computing on parallel computers, while supercomputing is computing on top 500 machines. Next is the example of supercomputing. Communicating sequential processes. One process is assigned to each processor. Work done by the processor is performed on the local data. Data values are exchanged by message. synchronization construct for inter-process coordination, distributed memory, coarse-grained, MPI application programming interface, commodity cluster, and MPP. MPP is acronym for massively parallel processor. Next is shared memory multiple thread. It is static or dynamic, fine-grained, open MP, and distributed shared memory system.
Speedup. Speedup can be defined for two different types of values, throughput and latency. Throughput will be given in the general form of completions per unit of time. In computer architecture, the common throughput metric is instruction per cycle, denoted by IPC. The reciprocal of this is cycles per instruction. This is a latency quantity because it is the length of time between successive completions or occurrences. Speedup is defined differently for each type so that it is a consistent metric. One of the most common measurements is computer architecture. The execution time of a program can be seen as a latency quantity because it is in seconds per program. For latency values, speedup is defined by the following formula. S equals to T old over T new, where S is the resultant speedup, T old is the old execution time, and T new is the new execution time. For throughput values, which are also called performance quantities, the enhanced performance will be in the numerator and the original performance will be in the denominator. Notice that speedup is a unitless quantity. This is because it is a relative quantity. Speedup is only useful when the experimental data is run on the same system, just with the slight tweak for which the speedup test is being run. The formula for speedup, S equals to P new over P old, where S is the resultant speedup, P old is the old performance, and P new is the new performance. Superlinear speedup. Superlinear speedup, sometimes a speedup of more than P when using P processes, is observed in parallel computing, which is called superlinear speedup. Superlinear speedup rarely happens and often confuses beginners, who believe the theoretical maximum speedup should be P when P processes are used. One possible reason for superlinear speedup in low-level computations is the cache effect resulting from the different memory hierarchies of a modern computer. In parallel computing, not only do the numbers of processes change, but so does the size of accumulated cache from different processes. With the larger accumulated cache size, more or even all of the working set can fit into cache, and the memory access time reduces dramatically, which causes the extra speedup in addition to that from the actual computation. One example is the reduction of RAM access time. This happens when the working set of a problem is greater than the cache size when executed sequentially, but can fit nicely in each available cache when executed in parallel. This leads to my first experiment in a shared memory multiprocessor model and the second experiment in a distributed system. The time spent communicating between processes relative to the total time spent performing parallel computations is called the communication overhead, and is a quantity which depends on both the multiprocessor interconnection network architecture and the implemented algorithm. For overhead, additional critical paths in time work required to manage parallel resources and concurrent tasks that would not be necessary for purely sequential execution. V is total overhead of workload execution, while Vi is overhead for individual task Wi. Each task takes Vi plus Wi time steps to complete. Overhead imposes upper bound and scalability. Performance issues in capacity computing. Throughput computing. Performance measured as total workload performed over time to complete overhead factors. Startup time, input data distribution, output result data collection, terminate time, and intertask coordination overhead. No task coupling. Starvation, insufficient work to keep all processes busy, inadequate parallelism, of coarse-grained task parallelism, poor or uneven load distribution.
Hello, good evening. Today I would like to present about the Module 2 Introductions to Distributed System which is Internet, Intranet, Mobile Ad Hoc Network, component. Driving the factor of distributed system, which is ever increasing need to share resource and information, distributed computing as a utility, more affordable powerful workstation, cheaper hardware, widespread use of network, pervasive networking technology, mobile and ubiquitous computing, maturity of software technology, distributed multimedia. Okay, failure handling for detect, mask, tolerate, recover, and redundancy, and the coherent for synchronization technique, transparency, perceived as a whole rather than collections of independent components, quality of service, which is reliability, security, performance, and adaptability. Goal of distributed system, which is a first efficiency, communication, load of distribution, flexibility, use of viewpoint, ease of use, consistency, reliability, system viewpoint, modularity, scalability, portability, interoperability. For robustness, can handle exceptional situation and error, change in topology, long message delay, inability to locate server, and security, reliability, protection, and Transparent. This is the transparency in distributed system. We can look at this table: access, location, iteration, relocation, replication, concurrency, failure, and persistence, and the description sheet. Software and hardware service layer in the distribution consists of four, which is the upper one is application services, and the second one is middleware, the third one is operating system, and the last bottom one is computer and network hardware. Okay, this is different basic organization and memory in distributed computer system. This is multiprocessor, example of bus-based multiprocessor. Okay, this is consists of two figure, which is first is cross point switch and the second one is omega switching network. Homogeneous multi-computer system. A is a grid, B is a hyper. Okay, this is of the software concept. Is an overview of DOS, NOS, and middleware. DOS consists of distributed operating system, not for network operating system. Positioning middleware, which is this is a general structure of distributed system as middleware. Okay, middleware and openness. In a openness middleware-based distributed system, the protocol used by each middleware layer should be the same as well as the interface they offer to applications. Okay, this is a comparison between the system for the comparison for the degree of transparency, same OS, number of copy, basis of communication, resource management, scalability, and openness. Okay, service concept consists of three, which is first is primitive service by system server, value added service. Okay, service primitive fundamental functions that the kernel must provide. Three minimum include functions, which is communication, synchronize, process, serving, manage the creation, deleting, and tracking the process. Okay, the service second is system service. Provide the fundamental service for managing process file and process communications. Example: name of server, directory server, network server, time server, and file and print server and authentication server. Now I would like to pass to my friend.
Hello, I'm Vinita and would like to continue about the services which are value added. Services that are not essential in the implementation of a distributed system but are useful in supporting distributed applications. High level and special purposes services. Examples are group servers to manage creation and termination of a group activities. System models. All distributed systems share important underlying properties which give rise to common design problems. These common properties and design issues can be represented as a descriptive model where each model is intended to provide an abstract, simplified but consistent description of a relevant aspect of distributed system design. Three types of system models are physical model, architectural model, and fundamental model. Physical model representation of the underlying hardware elements of a distributed system that abstracts away from specific details of the computer and network technologies employed, such as basement line physical model, early distributed systems, internet scale distributed systems, contemporary distributed systems such as mobile and ubiquitous, and cloud computing. Distributed system of systems, examples are environmental management system. Architectural model simplifies and abstracts the functions of the individual components of a distributed system and then considers where to place the components across a network of computers in order to define useful patterns for the distribution of data and workload. The functional roles of the components and the relationships between them. classify the processes into server process, client process, and peer process. Defines the way in which the components of systems interact with one another and the way in which they are mapped onto the underlying network of computers. Provides a high-level view of the distribution of functionality between components and the relationships, communication pattern between them. Determines the distribution of data and the computational tasks among the physical modes of the system. Helpful when evaluating properties such as performance, reliability, and scalability. Clients and servers. These are the example of general interaction between a client and a server. Types of architectural models are client invoke individual servers, browser and web server which uses a local file server, a service provided by multiple servers, replicated web server service. Web proxy server provides a shared cache of web resources for client machines. A proxy server is a server, a computer system, or an application that acts as an intermediary for requests from clients seeking resources from other servers. A distributed application based on peer process.
Using middleware, this is a general structure of distributed system as middleware.
Other variations of client-server models is mobile agents. Software agents are programs that assist people and act on their behalf. Mobile agents has the ability to transport itself from one system in a network to another. It is not bound to the network host where it begins execution. A mobile agent is a running program, both data and code, that travels from one computer to another in a network carrying out a task on someone's behalf. Compared to static agents that make remote invocations to some resources. There is a reduction in communication cost and time. Reasons for using mobile agents are reduced network load and client processing power, overcome network latency, encapsulate protocols, execute asynchronously and autonomously, adapt dynamically, natural heterogeneous, robust and fault tolerant. Drawback of mobile agents are security risk introduced. A computer virus is some kind of mobile agents. Mobile agents may be attacked, modified, deleted by hostile hosts. Spontaneous networking, a distribution that integrates mobile devices such as personal digital assistant and mobile phones and other devices. Key features: easy connection to local network, easy interaction with local services. Issues that involved are limited connectivity, security, and privacy. Spontaneous networking in a hotel. Example: processing level, the general organization of an internet search engine into three different layers: user interface level, processing level, and data level. Adapt dynamically, natural heterogeneous, robust, and fault tolerant. Modern architectures. Fundamental models provides a formal description of the properties that are common in all of the architectural model. The purpose is to specify the design issues, difficulties, and threats that must be resolved in order to develop distributed systems that fulfill their task correctly, reliably, and securely. Three key models that in fundamental models are interaction model, failure model, and security model. Clients and servers. These are the example of general interaction between a client and a server. Failure model defines the way in which failure may occur in order to provide an understanding of the effects of failures. Classifies the failure of processes and basic communication channels in a distributed system. Omission failures is a cases when a process or communication channel fails to perform actions that it is supposed to do. Arbitrary failure is any type of failure may occur or process may send wrong value or message content corrupted. Timing failure, which is no responses within a specified time for synchronous system. Masking failure, knowledge of the failure characteristic of a component can enable a new service to be designed to mask the failure of the component on which it depends. A service masks a failure either by hiding it altogether or converting it into a more acceptable failure. For an example, process crash can be masked by replacing the process and restoring its memory from information stored on disk by its predecessor. Security model. The security of a distribution system can be achieved by securing the processes and the channels used for their interactions and by protecting the objects that they encapsulate against unauthorized access. Identifies the possible threats to process and communication channels in an open distributed system. Threats related to integrity and privacy. Major design issues, which is some will be covered in this course, are object models and naming schemes, distributed coordination, inter-process communication, distributed resources, fault tolerance and security. Thank you.
Module 3. Communication in Distributed System. Models have four, which is remote procedure call, remote method invocation, message-oriented communication, and stream-oriented communication. Remote procedure call. A request made by a process in one computer to another across the network. Tend to operate in real time, required in applications, client-server application, also use RPC. The function of the above diagram is to make a remote procedure call look as much as possible like a local one. For RPC to execute a procedure at a remote site and ship the result back. The result of this diagram is to make this operation as distribution transparent as possible. Steps of a remote procedure call. First, client procedure call client start in normal way. Second, client start with message call local OS. Third, client OS send message to remote OS. Fourth, remote OS give message to server start. Server start unpack parameter and call server. Server does work, return result to the start. Server start pack in message and call local OS. Server OS send message to client OS. Client OS give message to client start. Then start unpack result and return to client. This is a client and server start. Asynchronous RPC is to avoid blocking of the client process. Asynchronous RPC also allow the client to proceed without getting the final result of the call. From the diagram, it shows that the interconnection between client and server in a traditional RPC. Server start unpack parameter and call server. Default synchronous is a one-way RPC model. Client and server interacting through two asynchronous RPC. Remote method invocation. The list of distributed object computing in the Java environment define how Java component can interoperate in a multiple Java VM environment. Provide the tool that programmers need to create distributed Java application and invoking a method is like asking another program to do something. Module 3. Communication in Distributed System. Remote distributed object. Objects separate their actual implementation from their interface and distributed object and remote object. Java RMI, distributed object integrated into the language. Goal is to achieve transparency. Any serializable object type can be a parameter to an RMI. Local objects are passed by value, remote objects are passed by reference. Proxy can be used as a reference to a remote object. Message-oriented communication, known as request or response, MOC is typically more decoupled than RPC or RMI. Module 3. Communication in Distributed System. Host and communication server can have buffers. With transient communication, discard the message if next hope is down. Persistent communication will store. How long should we store the message? There is also a spectrum between transient and persistent. Do we wait for the receiver to actually receive the message? Message can be synchronous. Persistent versus transient. Message-oriented communication, known as request or response, MOC is typically more decoupled. Asynchronous versus synchronous. Asynchronous, sender continue after submission. For synchronous, sender is blocked until message is stored at receiver host. Message is received. Response is received. This is an example of persistent asynchronous or synchronous communication. Topology of communication, client-server, peer-to-peer, and group. Message is stored at receiver host. Reverse protocol unsuitable if the service has to return data or the client has to know what happened to the service execution. Advantages: there is only one message involved, thus the network is not unnecessarily overloaded and the client can continue execution as soon as acknowledgement of message delivery has been returned. Reverse reply acknowledgement protocol. Depending on the amount of client or server communication cycle, the maintenance of history may involve a serious overhead. The RRA protocol is designed to limit this overhead. RRA adds to RR an additional acknowledgement message, which is sent by the client as soon as a reply has been received. The receipt of acknowledgement message enables the server to dump the reply message of the communication. Point-to-point communication involves exactly two processes: server variation on how the sending of a message can interact with a program. Synchronous. Asynchronous communication does not complete until the message has been received. Asynchronous. An asynchronous communication completes as soon as the message is on the way. Blocking and non-blocking. For blocking operation only return when the operation has been complete. For example, normal fax machine. Non-blocking operation return right away and allow the program to do other work. For example, receiving a fax. Group communication concept: broadcast send message to a group while multicast send message to subgroup only. That's all from Module 3. Thank you for listening.